Welcome back to another Daishinfinity video. In this video, we are going to talk about the Pythagoras theorem, and we're going to prove this Pythagoras theorem: a squared plus b squared is equal to c squared, with using geometric analysis. Now, this geometric analysis is taught in Germany, especially when I was in college. So I would like to prove this formula by my own proof. So enjoy the proof and let's start. So the way I started is I started with the sides A and B, and between the sides A and B we obviously have the angle gamma, and the side that is opposite to gamma is the side C. Now let's draw this triangle a little bit bigger so that we'll get a bigger image. Let's say this is gamma and this is C. So this is the hypotenuse, let's say, for any right triangle where gamma is 90 degrees. Now we're not going to talk about the right triangle right now. We're going to try to dissect this triangle into many different parts. So the first thing I'm going to do is I'm going to let A be a vector. So A as a vector, and I'm going to let B also be a vector pointing to this direction, which would also mean that C is either the absolute value of the vectors A minus B, or just the absolute value of B minus A. Now, I've forgotten something about A and B. The side length of A is not the vector A. The absolute value of the vector A and the absolute value of the vector B is equal to the side length of A and B of this triangle. Now what I'm going to do is I'm going to split this triangle into two by dissecting this into two halves and putting a right triangle. So we have two right triangles over here, 1 and 2. And as you can see, we can put simple angles to it. So this is going to be alpha. This is going to be beta, because beta is opposite of B, and alpha is there because it's the opposite of A. Now, if we talk about the relationship between angles, we know that the cosine of alpha is the scalar product of the vectors A times B divided by the length of A times the length of B. Now we're going to use this understanding in our sketch. So we're going to use this and use another color, for example purple, to demonstrate this length and this length. This length and this length, we can obviously describe it. So since we have the vectors over here, we can just simply say that cosine of beta is equal to the one which is A times B minus A as a vector divided by the length of those vectors. Now the same applies for cosine of A, which would just take the vector B into consideration. So this is the actual formula we have over here. And since we know that C can be expressed in another way, C, we just talked about it, is the vector B minus A or A minus B. Now let's look back at the sketch. The sketch tells us we can take the angle and put it into relation. So let's talk about this length over here, which is in purple, and let's take this length A. So we can take the angle beta and the side length A to do a relationship to get the side of that purple color. The answer is the cosine of beta times the length of A, and over on the other side is just the cosine of alpha times the length of B. So C can be expressed as the cosine of beta times the length of A plus the cosine of alpha times the length of b. Now we're going to take this as a sample so that we can plug in cosine alpha and cosine beta, which is equal to these things, and plug it into our equation. So we're going to write c is equal to, now this is going to be a very big equation because cosine of beta and cosine of alpha is a big fraction. Cosine of beta is the same thing as a, vector a, scalar product times b minus a, as a as an absolute value divided by the length of a times the absolute value of b minus a times the vector a. You're not allowed to forget the other parts of the equation, plus cosine of alpha is just b minus a divided by the length of them, and just multiply everything by the length of b. Now since you see the both c, a and b will cancel out, where a and b, the length of them are not equal to 0, which will never happen because then we will not get a triangle. And now because of the common denominators, we can put them together, so we'll just have b minus a as absolute value, and we have the scalar product b minus a plus b minus a. Now what is the absolute value of b minus a? B minus a is the same thing as c, so this is equal to c, so we can multiply both sides by c. We'll get c squared is equal to ab, using the a times b scalar product, using the distributive rule, ab minus a times a, absolute value, plus b times b minus b times a. Now whatever you think about the vectors a and b, if we talk about the triangle we did earlier, this was the vector a and this was the vector b, pointing in this direction, and let's say the angle between these two is called gamma. So the cosine of gamma is equal to the you see the cosine of gamma is equal to the length of a, not the length, the absolute value of the scalar product of those two divided by the length of them. So I need to multiply those on this side to get the scalar product formula. Now if gamma is 90 degrees or pi over 2, cosine of pi over 2, if we look at the graph, cosine starts with 1 and slows down and goes down to 0 at 90 degrees, or in radians, pi over 2. So 0 times anything will be 0. So every time you have an angle of 90 degrees or 270 degrees, which is just the negative of the scalar product, you'll get 0. It means that this is going to be 0 and this is going to be 0, and we're going to have that c squared is equal to negative the scalar product of a times the scalar product of a plus the absolute value of the scalar product of b times the scalar product of b. Now if we talk about scalar products of both same vectors, it's just going to be the cosine of the angle between them times the length of them. Now the length, we can write it as simple alphabets equaling a squared. And since cosine of alpha, the angle between these two is just 0 degrees, so we have even radian is 0, so cosine of 0 is 1, which means it's a squared. So we'll just replace the formula over here, just write in c squared is equal to the absolute value of minus a squared plus the absolute value of b squared. Now since we have the absolute values on both sides, and we are going to take the negative, put it to the positive, and we'll just get that c squared is equal to a squared plus b squared. And now we have proven this formula, we can put a small box there, and I hope you really like this video. This is personal proof from my side, and I hope you really enjoyed this video. Now see you in the next video, and please subscribe and like and comment if you want. See you in the next video. Bye.